So you said number 8 on snapshot number 3. Did I get it? Okay. So the problem starts as 18 h to the 5 m to the 4, and it's over 9 h to the 12th and m to the 5. So we're just going to hit this in 3 parts. We're going to start with the numbers that have nothing to do with algebra. 18 and 9 can both be divided by 9. If you divide them both by 9, 18 becomes a 2 and 9 becomes a 1. So we know right now that our answer is going to have a 2 on top and a 1 that I'm not going to write on the bottom because there's never a time when putting a 1 there would make sense. On top, you put it, on bottom, you don't. And then we're going to just subtract with our variables. Because now we're doing exponents, so we treat them differently. We don't actually like reduce 5/12ths. We subtract 5 minus 12. And that equals negative
Oh, oh.
7. So I have h to the 7th power, but because the answer that I got was negative, that means there's more of them on bottom than on top. I'm going to put the h to the 7th on the bottom. When it comes out as there's more on bottom than top, you're going to see that by the answer to that subtraction being a negative. And then you're just going to do it again with the m's. So you're going to go 4 minus 5, and that's going to equal negative 1. So we're putting m to the power of 1. And some people still put the ones. It's not wrong. It's just weird. So we're going to take m to the power of 1. And because it's negative, we're going to put it on the bottom like that. That's it. I mean, those problems like 8 and 9, you just have to attack in 3 swipes. You basically just go like this. You just go swipe number 1. Oops, my bad. Swipe number 1, reduce. Swipe number 2, subtract. Swipe number 3, subtract. That's it. Anything else? Sure. Okay.
You go for 9 and 11.
Sure. So number 9 is going to be basically the same problem as what I just did. It just has a little bit of extra stuff. Girls, let's just work. Girls, let's just work. That's all I want to do today is just work. No shooting the breeze. Are you guys looking at me weird? Yeah, let's just work. No, just full productivity today. And then we have k to the 13th and x to the 9th. So my explanation isn't going to change a bit. I'm going to attack the numbers first, and I'm going to realize that both of those numbers can be divided by 4, right? And I'm right now going to pay mind to the fact that there's just one negative in the problem. And that means that my answer is going to be negative. So I would always do that first, just kind of just get that out of my mind. And then if I get the negative out, I can just kind of erase it and not ever worry about it again. You still good? And then when I reduce the 4 and the 20, they can both be divided by 4. Leaving a 4 divided by 4 is 1 and a 20 divided by 4 is 5. So my answer is going to have a 1 that could get erased in a bit if I don't need it, but it needs to be there for now, and a 5. Still good? And now all you got to know how to do from here is subtract. And I'm a firm believer, I'll die on this hill, that anyone enrolled in a 9th grade math class should be able to do basic addition and subtraction. If that's not true, that's our job to fix it. I can help. But we should all know that K comes before X in the alphabet. So I'm going to do 15, since there's 15 Ks on top and 13 Ks on bottom. You and I both know that 15 minus 13 is positive 2. So I'm going to put K to the power of 2 on top. You with me? And then I'm just going to go again. I'm going to go round 2. I'm just going to find my X's. There's an X over here, and there's an X over here. And I'm going to go 14 minus 9, which again, everyone in this room should know is 5. And since it's positive 5, I'm going to put X to the 5 on top. And I realize now that I don't need the 1 anymore because it would have been a placeholder. So all I would do with this answer is I would just make it look a little less ghetto-y by maybe moving the 5 over here. I would imagine what a lot of people did was they just lazily assumed that the X's would be above each other in the case. I don't know for a fact, but like you got to be more vigilant than that. You know, you need to look around and make sure that the right guys are going with the right guys. K's go with K's.
X. K. Well, is it wrong if you leave for one, or is it?
No, it's just weird. I mean, again, a lot of people leave ones. I would hope that it's one of those things we eventually stop doing, but it's if it for now it's not wrong.
Hmm.
Did you ask for another one too? 11? Sure. So it's so you're in the bottom row now. So this when we start doing our harder snapshots, this will be what as 1 through 9 right now are my baseline expectation. Problems like this will be the baseline expectation next week. So but I'm glad you're asking. So
And this one we're gonna multiply or distribute.
we're going to distribute because it's the order of operations mandates that we distribute before we because distribution.
Since it's a negative.
No, you could distribute it. You just don't ever want to try to figure out what it actually equals.
Oh, okay.
Like if you wound up with like a 4 to the negative second power, you don't want to try to figure out what it is. You want to move it and then figure it out. But no, distribution is always going to be what we do first. So like we have a 6. Let me write this down first before I get your question. Go ahead.
So you said that, like we should wait to like solve that exponent.
Yes, anything with a negative exponent, you should wait to figure out. Um,
Like, what would be the difference if you do it and you don't?
Just don't, because you're going to, there's a 98.6% chance that you're going to get it wrong if you do. And I've got 29 and a half years of experience of telling me that if I'm not careful to be bossy about this, then I'm going to hear kids say really stupid things like, oh, 5 to the negative second. Ooh, I know it's negative 25. If that equaled negative 25, my job would be so much easier, but it doesn't. And so that's why we want to be careful that when something has a negative exponent, it doesn't equal what you think it does. It's crazy. Like negative exponents cause real havoc. And if you're not respectful of them, they're going to cause you to keep missing problems. Now, if in the middle of a problem, I got 5 to the second power, I would just write 25 because I know that that's what it equals. Negative exponents, you need to fear them and run the other way. Okay. All right. So what we're going to do first on this problem is we're going to first off ignore the 3. Who do you need?
No, but.
There's only one thing I can say for sure, Jojo, about this answer right now, and it's that this number 3 is not going anywhere. It's because it's not right. It's not in the parentheses. So anything I'm about to do isn't going to affect that number, right? So what we are going to do is we're going to take this exponent that I'm circling in green, and we're going to feed it to the m, and we're going to feed it to the n. Okay. So the m already has an exponent of 3. We're going to do 3 times the new exponent, negative 2, which means now we have m with a negative 6. Stop me when I lose you. I mean, that's, I think, one of the most important things in our relationship is that when I do something, don't like get upset or pouty about it. Ask a question, be proactive and ask, what did you do? How did you get that? Do you understand how I got that? Okay. Now what we're going to do is we're going to take the n that really doesn't have an exponent. I mean, you could make a case that it has an n to the power of 1. Some people that helps them. Doesn't matter. At the end of the day, when you do the second distribution, you're going to have some n's, but it's going to have a power of now 1 times negative 2, which is negative 2. Are you still with me? Now, to Natalia's question, this is where it's critical that you listen and that you not math what I'm about to get. Let me show you something. Pay attention to where I'm moving my pen. Do you see my pen? If I were to erase this negative, do you see what I just did? Then right here where it says 2, I would take 6 to the power of 2 and I would write 36. Because I know and you know we're both big kids that 6 times itself equals 36. However, in this problem, that 2 that I'm circling in red is negative, and you got to go high red flag alert now and say, okay, I'm about to put a negative exponent on a regular number, and that means I am not going to try to figure out what that equals because it does not equal 36 and it sure does not equal negative 36. So you write it down, run away for a bit, go do some other stuff, and then come back later. Are you with me? Okay. Now we're going to distribute. So I already distributed the -2 onto the 6 and just wrote it down. I didn't math at all. I just literally applied the number to it. Bless you. And then I'm going to take the m and I say you already have a 6. 6 times -2 is -12. And then the n already has a -2, and -2 times -2 more makes +4. That is step one of about 3 or 4 steps that we have to do. But getting you through that step it's hard. I talk a lot, but at the end of the day, I got to be honest, I really haven't done much of anything. The only math I had to do was like 4th grade stuff, like 3 times -2. Are you kidding me? Like that was the only math that I had to do. But now I've got to understand some things about algebra. The next thing that you should think about is that step 2 that we talked about last week, I think it was. And that is we should go now and pick your favorite colored pen and go around and circle all the things that you don't like. These 4 things that I'm putting these purple eggs, jelly beans around, I don't like. Why? Not because they're negative, but because their exponents are negative. It's not about what they are, it's about what their exponents are. So what we're going to do is we're going to rebuild our answer and we're going to copy down all of the things that didn't move. I know that there's still a 3 here, and I know that there's still an end of the 4th here. Do you see that? Okay. Now, the order that you do this in, it doesn't matter. If anyone tells you they care, then they're like a control freak or a micromanager. Like, who cares? I'm going to make a mess. I'm in sandbox mode right now. I'm just playing around, moving stuff around. So, like, I choose to move the red and purple one up because I want to. Quite frankly, I like my numbers to go together. So rather than worry about like where the M's and N's are going to go, I'm going to worry about the numbers first. So I'm going to take that 6 and I'm going to move him upstairs. When he gets there, he says, my name is still 6, but now I have a proper exponent of 2. And then I'm going to take this purple M on the bottom and I'm going to move him upstairs. And he says, my name is still M. I didn't change, but my exponent did. And then I'm going to take this one that I'm circling in yellow. Again, I'm not doing this in any scientific order. I'm just doing it in whatever order floats my boat. And I'm going to move that M downstairs. And he says, I am still M, but I am now the proud owner of a proper positive exponent. And then this green one says, well, I better join you down there because I've also got a bunk exponent. And so he goes downstairs and says, I'm still N, but I'm to the power of 2. I'm trying to be as repetitive as I can about these steps. The next step is to clean up the top and clean up the bottom. You should do that before you do step 4, because step 4 is like the compression step. If you look back at problems 8 and 9, 8 and 9 are just compressed problems. Those are where we just press it from top to bottom and reduce everything down. We're not ready for that yet because I've got some messes to tidy up. So here are the messes to which I'm referring. First off, I do not want to carry this around for the rest of the problem. I'm going to math it. And because I'm in high school, I'm not going to use a calculator. What is 6 squared? It is 36. So I'm going to take that 6 squared and I'm going to write it not as 6 squared. I'm going to get rid of it and call it by its now actual name, which is 36. And honestly, while I'm here, I see more math that I can do. The word simplify is all encompassing. It means just do math for God's sake. Divide, reduce, multiply, exponentiate, subtract. Simplify is just, it covers everything. Do you know what 3 times 36 is? It's okay if you don't, like for real. It's 108. Very good. And then I realize now that the top is quite literally the best version of itself that it's ever going to be. There's nothing else that I can do. But then I look across the bottom and I realize, I bet these 2 yellow things would like to go together. What do they make? So I have M to the 6 that was just already hanging out, and I have N to the 6 that I just made. And now this problem is back to exactly what problems 9, 8, and 9 started as, and that is compression, reduction, combining. So when you work downwards, the 108 has nobody. If there was anyone for this 108 to reduce with, it would be right there. It's not there. There's nothing there. So like you can do nothing about the fact that your final answer is going to have a 108 and there is nothing getting in the way of that. Does this M on top have anyone on bottom to join with? And how we got to use our properties. How are we going to combine them? Yes, we are. We're going to take 12 minus 6, which is positive 6. So I'm going to put M to the 6th on top. The only thing left is N. And he's like, he looks around and goes, I got nobody. So it just sits right there and you are done. Those problems are not simple. They would be if I could get 57 teenagers at the exact same time to agree to follow directions. That's the hard part of this job. I can get 28 of them, and then the next day I get a different 20, and then of those 28, 14 of them decided we're too good at this and they don't want to listen. It's almost impossible. But if I could just get everyone to do step 1, then step 2, then step, man, it's a tough job, this one. So that's all I need from you is just to embrace the fact that there are steps. And if you do them in the same order every time, you're just not going to go wrong. Now, if you subtract like a goofball, if you say like 5 minus 8 is 3, I can't help you. We have to work on those basics, right? But assuming that all the basic skills are in place, then this is just take your time, do the steps. Yeah. Assignment 17, question 11. I'm on it. Let's take a look at that. You said problem 11 on assignment 17. Got it. So this is going to be, if anyone's eavesdropping or not eavesdrop, that's maybe not the right word. If anyone's kind of along for the ride, this is assignment number 17, problem number 11. And it starts out, it's not even a fraction, right? So it's 4 and then x to the second, and all of that is raised to the negative 4th. Is this the right one? Okay, so what we're going to do, this has got to be like a monkey see, monkey do. Monkey see parentheses, monkey do distribution. Like, I'm not saying you're a monkey, it's just an expression, right? So I'm going to take this exponent and I'm going to say, I want you to go be his exponent. And that again is I'm still not getting through. That is the biggest mistake you can make, is to try to figure out what this equals. It does not equal 256. Trust me on this one. Listen, here's what you're thinking. You're thinking that this negative is not here. And if it's not there, in your defense, 4 to the 4th power, I get it. It's 256. 4 to the negative 4th is like not even close to the same thing. They're not even in the same ballpark as each other. Like one's playing baseball in Tampa and the other one's playing hockey up in Ontario. These are not the same. You stay away from that. Do not math it yet because it has a negative exponent. Did you get that? Huge. Now what we're going to do is we're going to take the red circled exponent and we're going to give it to this one. And he says, I'm x, so I'm still x, and I already have an exponent of 2. So take my current exponent and multiply it by the bigger, not the bigger, but the taller, the higher one up there, and you get now an x with a negative 8. It's at this point that we are in every problem, you have to ask yourself, do I have any booger negative exponents? And if the answer is yes, then you are going to take time out of your day and you're going to move them. And there's only 2 ways a thing can move. They can either move up or they can move down. And in this case, you don't see this as a fraction, I understand, but everything is a fraction. You can make a case. I could say the number 5 is a fraction because it's 5/1, right? So we don't see it this way, but we understand that those are currently in the quote unquote top of the fraction, correct? What do you do with things when they have negative exponents? You move them. If they're on the top, you move them down. If they were already on the bottom by some chance, you move them back up. That's all you do. And when you move this down, it's still a 4, but its exponent is now +4. Now we don't have to run away. Now we can find the 256 where we should have found it in the first place in the bottom. And then when you pick this up and move it downstairs, it doesn't change. It's still X, but its exponent changes, right? It's not the 4 and the X that are changing. It's the exponents that are becoming positive. In the absence of everything, we have just gutted this entire fraction. We literally took everything out of the top of the fraction, leaving absolutely nothing up there. And in the absence of anything, you put a 1. And then you can math now. So now you can exponentiate to your heart's content. 4 to the 4th is 256. X to the 8th is X to the 8th, and you're done. I cannot stress enough. Yes, very wrong. That would be like if the answer to a problem was like if a teacher drew a picture like in a little kid class and said, okay, here's a pizza, and the green part of the pizza represents how much of the pizza Sally ate. How much of the pizza did Sally eat? And a kid wrote that much. Would that freak you out?
Yeah.
Yeah, I mean, fractions are not, they don't exist if they don't have numbers on the top and the bottom, right? So 1, again, I want to stress is what we call a place holder. When there's nothing on the top, you need a 1. Good? Your big takeaway from the last 3 minutes, 4 minutes of our time together is when you have a negative exponent on a number, do not evaluate it. Do not solve it, as you kids like to say. Don't figure it out. Move it first, then figure it out. Yeah,
Um,
sure. Oh, so the new assignment number 10? Sure.
no, 7.
That's okay. Trying to mess with me. So yeah, this is going to be a pretty quick one. Bless you. So we have -4, X to the 4, Y to the 4. And this is all over -2, X to the 3, and Y to the -4. You tell me, what would be your first sort of gut instinct as to what you should do?
What?
Like just reduce it? Yeah, I think that's a smart play. There's going to be, there was another thing you could have said that I would have been okay with, but I really like attacking the number parts first. I don't have any negative exponents on the left side to work with. I will tell you this, if either of these red things had a negative exponent, then you and I are having a very, very different conversation. But that's just a little fifth grade problem. Like -4 and -2, you and I know that a negative reduced with another negative becomes a positive. So I can just get rid of the negatives. And you and I both know also that 4 and 2 can either divide or reduce, however you want to say it. The net result is 2/1. So at this point, our final answer, it's not final. I'm just saying, like, I have a vision or a picture now of what my answer looks like, and it looks exactly like this. So the question becomes now, having tackled that simple little kitty part, how do I do the algebra? Well, let's look for things that can be dealt with. What do you see? You can. You're still avoiding something. I see what we're doing here, and I'm fine with that. I'm okay with the fact that you have an X to the +4 on top and an X to the +3 on bottom, and I'm okay if you want to just put those together right now. 4 minus 3 is 1. So we get X to the power of 1. And since it's positive, since this number's positive, we put X to the power of 1 on top. But you're still avoiding something, the -4. And again, for years and years and years, I taught this as take the top exponent minus the bottom exponent. But if I had $1 for every time some kid tried to tell me that that equals 0, that they quote cancel out, I could probably pay off my car. And that's bad. So what I decided this year was, rather than watching people butcher subtraction of a negative, that's why I'm being bossy this year about negative exponents. Let's not go there. Let's not try the math. Do I think you could do that? Yeah, but I want to play the odds and get the most bang for my buck. So rather than worry about mathing the 4 and the -4, I'm not going to. I'm going to take this one, the yellow jelly bean, and I'm going to move it upstairs, Dave, because I don't want to deal with the negative exponent. If you move it upstairs, what does it become when it gets there? I get that, but like, what the yellow jelly bean can be rewritten now as y to the power of +4. And he no longer exists down here. And we've put ourselves in a pretty sweet situation now where we have two y's that I don't even have to subtract. Look, they're right next to each other. So we add their exponents, we get y to the 8th. And it turns out that my answer with that weird fraction line was unnecessary because there's nothing on the bottom. And only like a weirdo would put this, right? So we're not going to do that. Instead, what we're going to do is just say, done. You follow the flow? I really was kind of partially hoping that like the first thing you would do in this problem was to tackle this, but you didn't. You kept putting it off and putting it off, and that's okay as long as you get to it. Yeah. Do you guys have other questions? Or is she good? You finished them both already? Nice. Did you grade them? Nice. Good work. And C, you good?
Pretty much supposed to look to the side. I think two.
On
Like,
which assignment there, kid?
oh, God, I'm stuck.
Yeah. I sometimes wonder, and I'm never going to do this, but I wonder to myself, if I put like an awkward space here, if I could help you guys be better at this. I'm not going to, because it'll set you up for failure in later classes, but I just want to make sure that you and I are both really clear that there is a -3. He's his own man. And there's an A. He's his own man. Are we clear? Okay. So step one just has to be, we have to convince ourselves that step one is to take that exponent and give it here and give it here. So we're going to take that -3 and we're going to give him the power of -4. And remember what I said, we are not going to try to figure out what that equals, right? Because the negative exponent says run and you run. Okay, good. Now we're going to take that second red arrow, the A. What are we going to do with these two green numbers? Correct. And what is -3 times -4? Nice. This is the point at which we assess the landscape. We don't do any math in this step. This step is where we move things with negative exponents. And so I look at this and say, A to the 12th, you're pretty good. Just hang out for a minute. I have a job to go do, and I'll be back in a minute. So A to the 12th says, all right, I'll just kick it here while you go do whatever this weird job is you have to do. And you say, I'll be right back. And then you take this purple one and you say, I'm going to label you as a bad guy. Why do we hate him?
His exponent.
Your words are gorgeous. You didn't say because it's a negative. You said because his exponent is a negative. And that's the key. So you now have to build a fraction and make a place for little Mr. Dumb -3 to go. And he says, I'm still -3, but look, hey, I done fixed myself up. I got a positive exponent now. It's at this point that you now have a green light to do math. What is -3 times -3 times -3 times -3?
Positive 8.
You bet it is. Nice.
That's where I screwed up because I did not.
That's I never know from year to year what my speed bumps are going to be. Some years I have it must be the words I say or the tone that I use, but some years my students struggle with one thing, and then the next year I'm like they struggle with something else. This year I'm finding the big one for me is this purple thing. I somehow have to get everyone to fear those. Fear them. You see a negative exponent on a number, run. Put your hands above your head and run, right? But don't run too far because you got to come back and deal with it. Yeah. After the fact?
Yeah.
Are you talking about the problem I just did? Um, number 17 on problem 17 on number 17. Seriously? That's crazy. That it's 17 on 17. That's nuts. You mind? Can I just hop in and we just do this together? So we have a -3, we have an X, and we have a Y, and we have an exponent that says, I shall distribute myself to all those clowns inside, right? And one at a time, very patiently, we are going to take this exponent, and we're going to give it to everybody. The -3 says, I accept your donation of an exponent of 3. I would not, if I were doing this by myself, I would not run away from that. I would work it, but I'm not going to right now. I'm just saying that I'm not afraid of that. Why? Why not? You bet. And so when the exponent's positive, I can actually math it. I can logically say, oh, so you want me to do -3 times -3 times -3. We'll come back and do it later. Sound good? But in this case, if you did it, I wouldn't be upset. Now I'm going to take the X and I'm going to say you already have an exponent of -1. What do we do with these two reds? We do. And we get X then with a new power of -3. And then we go again. We say Y already has a power of -2, and we're feeding it a new exponent of 3, and -2 times 3 is. This is what your problem should look like right now. What it is right now, there's an old song from the 80s by a band called The Clash. And my band in high school, we actually did a cover of this song. It's called Should I Stay or Should I Go? And we're kind of at that stage of this problem right now where we're not so much worried about the math as we are just getting everyone to where they need to be. Bad guy. Bad guy. Do you know that song? That has to be your mindset after step one is who am I keeping? Who am I moving? Should I stay or should I go? So when I rebuild my answer now, I'm going to leave my -3 on top because his exponent is fine. But on the bottom, I'm going to relocate my X, change his exponent. I'm going to relocate my Y, change his exponent. And the only thing left to do now is the math that, like I said, you could have done it right away and I would not have been upset. Correct. Correct. And the only thing, Chele, that I would say is I personally would put the negative out here and just put 27 up here. Because math people, generally, how we feel about negatives is we don't want a single negative embedded somewhere in a fraction. We like to filter it out to the front and then just let everyone be who they are. You with me? You feeling it?
Yeah.
Good. I'll just leave this on the recording. When I see you tomorrow, I'm going to make an assumption. I hope it's not erroneous, but if it is, it'll be your fault. I'm going to assume by the time I see you tomorrow that assignments 17 and 18 are both done and that you've gone onto Canvas to check your answers and that you're prepared to ask about the ones you missed. That'll be what I assume when I see you tomorrow. 23 hours and 15 minutes from now. And again, I know it's weird since I don't collect things. You're like, why would I do it? That's fine if that's how you roll, but what I do will be based on that assumption.
Oh, God. Yeah.